All right, good day to you. It's the first week, it's the first day of the week, and that's Monday. And how about you guys are attending classes? For the primary category, you're welcome to class. For today, we're going to be dealing with indices and logarithm. But the first topic that we're treating is indices. That's the first one we're going to treat. And your classwork and assignments are going to be in the classroom. So you can go back to the classroom when you're done with this and check for your classwork. Do the classwork is just a quiz and also do the assignments as well. We'll be treating the corrections in the next class. All right, so let's get to it. So the first thing we're going to do is the laws of indices. And the first one we're going to talk about is the multiplication law. Now, talking about multiplication law, it's simply put at this. For multiplication index, it says that when two powers, when we have, let's say we have x raised to power a times x raised to power b, the law is telling us that this turns out to be x raised to power a plus b. And I'm going to explain why. So now, because the base are the same, if you check the base, you can see that it's the same. So I can give us an illustration on something like this. I can give us an illustration on something like this. I can say 2 raised to power 3 times 2 raised to power 2 is equals to 2 raised to power 3 plus 2, which is 2 raised to power 5. And there's a way I can explain this. 2 raised to power 3 means 2 times 2 times 2. And 2 raised to power 2 means 2 times 2. So if I multiply them all together, I'm going to have 1, 2, 3, 4, 5. And that's giving me the 2 raised to power 5 we have there. So you can see that when we're dealing with multiplication index, what we need to do is that we need to add the indices. We add the indices together when we're dealing with multiplication index. And that's the law. Now, the law is also applicable, telling us that if I have something with different base, I have x raised to power a times y raised to power b, I cannot multiply or I cannot add the index together. Why? Because these are two different bases. There are two different bases. So in other words, I cannot have 2 raised to power 3 times 3 raised to power 2. I can't do anything. I can't add the base together. Instead, I leave the answer like that. I leave the question like that because they have different base. 2 and 3 are not the same. They have different base. All right? So that is multiplication index. Okay? That's the explanation of multiplication index. Let's check the next one. Let's check the next one. The next law is division law. So let's talk about division law. Now, for division law, the law says if I have x raised to power a divided by x raised to power b, it's simply put as x raised to power a minus b. So the law says I subtract the indices. So this is trying to tell me if I have, per se, let's say I have 2 raised to power 3 divided by 2 raised to power 2. This means 2 raised to power 1. So this is 2 times 2. Let me express it better. So I have 2 raised to power 3 divided by 2 raised to power 2. So if I should express this, this is 2 times 2 times 2. Yeah, sorry about that. So divided by 2 raised to power 2, that's 2 times 2. And so by our division, normal division knowledge, we're left with just 2 raised to power 1, which is equals to 2. So you can see the application of division law. You can see where it applies. So we have that. We have, whenever we're dividing indices, we need to subtract the index together. So if I have x raised to power a divided by x raised to power b. This is simply put as x raised to power a minus b. Simply put. All right, so the next that we're going to be looking at is the zero index. The zero index tells us simply that anything raised to power zero, anything raised to power zero is equals to one. So if I have x raised to power zero, it is equal to one. If I have two raised to power zero is equals to one. If I have 100 raised to power zero, it is equals to one. So anything raised to power zero is equal to one. And the next we have is the negative index. The negative index, that's the next one that we have, the negative index. And this law says that when we have anything raised to a negative, let's say I have x raised to power minus a. Now look at that very well. You can see that the power is minus a. Okay, you can see that the power is minus a. So whenever we're dealing with indices, we understand that we're dealing with powers. Powers are paramount when we're dealing with indices. So you can see what is raised there is minus a. So that minus represents a fraction. Take this minus. Wherever you see this minus, it represents 1 over. So this is going to give us x over a. 1 over x over a. Wherever you see the minus. So if I have something like this, let's say I have 2 raised to power minus 3. What this means is what? 1 over 2 raised to power 3. If I have something like this, if I have 4 raised to power minus 2, so what this means will be what? That will be 1 over 4 raised to power 2. So whenever we're having a negative index, we need to find a fraction of that index, the fraction of the base and the power, the fraction of the base and the power. What if we have something like this? What if we have a fraction? Let's say y over x raised to power minus 1. So automatically this means 1 over y over x. And remember, when you're dividing a fraction, it becomes 1 divided by y over x. And when you're dividing a fraction, division sign changes to multiplication sign, and then we have an inverse, x over y. So it means, so we're going to have x over y. So it means that if we have a fraction and it is raised to a negative, all right, if we have a fraction and it is raised to a negative, all we need to do is get the inverse. So if I'm having y over x raised to the power minus 1, this means x over y, according to how we just defined it. So what if I have 1 over x raised to the power minus a? What is this? What does this mean? This means what? This is going to be what? X over 1 raised to the power what? A. I hope we're getting it. So whenever we are having a fraction with a negative index, all we need to do is find the inverse of that fraction. The next we're going to be looking at is the power index. That's the next one we're going to look at. That is the power index. And for the power index, it says if we have x raised to power a power b. So it is telling us that we multiply the indices together. So in power index, we multiply the indices together. So if I have 2 raised to power 3 raised to power 2, again, so 2 raised to power 3 raised to power 2, this means 2 raised to power 6. It's just like saying you have 2 raised to power 3 twice. Let me explain that. It's like saying you have 2 raised to power 3 raised to power 2, right? So this means 2 raised to the power 3 times 2 raised to the power 3. And if we use our multiplication index, we know we're going to add the indices together. This is 2 raised to the power 3 plus 3, which is equals to 2 raised to the power 6. So you can see that. So whenever we're having a power index, what we do is that we multiply the index together. That's what we do. We multiply the index together. What we do is that we multiply the index together. All right, so let's take this. With the next one that we're going to have is called the fraction index. That's the fraction index. Now, if we're talking about the fraction index, we have something like this. We have x, sorry, we have x raised to the power 1 over a. Now, look at this closely. Whenever you have a fraction, the first thing you want to do, a fraction index, the first thing you want to do is determine the power, the roots of the denominator. D is over a, right? So the root of the denominator, and then the base comes inside to the power of the numerator. I'm going to say that again. If I have, let's say I have 2 raised to the power, sorry, let's say I have 8. I have 8 raised to the power 1 over 3. So the first thing I'm going to do is the root of the denominator. The denominator is 3 of that fraction to the base, and then the power of the numerator. So if I've got if I've got 8 raised to the power 2 over 3, this is going to be the root denominator of the base power 2. So if I have 9 raised to the power 2 over 3, or let's say I've got 27. Let's put something that is more definitive. Let's say I have 27. So this is going to be what? The root of the denominator with the base, the power of the numerator. So are you seeing that? So whenever we have a fraction index, that is what we do. That's how we interpret it. All right. That's how we interpret a fraction index. So in other words, if I have x raised to the power b over a, this will simply mean the root of a, x to the power of the numerator b. I hope we're seeing that. I hope we're seeing that. All right, so these are the basic laws of indices, and they'll be applied in the problems that we're going to be dealing with. Next up, ordinary indices problem. Ordinary indices problem. So we're going to be looking at some problems here that we're going to solve together. And the first I want us to look at, we're going to have to evaluate. Let us evaluate this. Um, if we're asked to evaluate, let's say we're asked to evaluate 8 raised to the power 1 over 3 times 5 raised to the power 2 over 3 divided by 10 raised to the power 2 over 3. So take time and jot that down. Just take time and jot that down. So I have 8 raised to the power 1 over 3 times 5 raised to the power of 2 over 3 over 10 raised to the power of 2 over 3. Now, whenever you're dealing with indices, remember to reduce the numbers to their lowest forms of powers. Reduce the numbers to their lowest forms of powers. Now, I know that 8 as a number can also be expressed as 2 raised to the power 3 in index form, right? Okay, so since 8 can be expressed as that, the equation now becomes, instead of me having 8, I'll have 2 raised to the power 3, right? As my 8 raised to the power 1 over 3 times 5 raised to the power 2 over 3 divided by 10 raised to the power 2 over 3. Now, I want to express 10 in its lowest form, in its lowest prime numbers, because I can see 2 in my numerator and I can see 5 in my numerator. I need something I can work with. So I have to make the mathematics very easy for me. So I'm going to express 10. 10 can be expressed as 2 times 5. 10 can be expressed as 2 times 5. So if I'm having that equation, I'm going to have 2 raised to the power 3 times 1 over 3 times 5 raised to the power 2 over 3 divided by 2 times 5 raised to the power 2 over 3. And if I should open the equation, this becomes, remember that this is power index. And for power index, we're going to multiply the powers together. So this becomes 2 raised to the power 3 over 3 times 5 raised to the power 2 over 3. Sorry, seems that is taken, can't see it clearly, times 5 raised to the power 2 over 3 divided by 2 raised to the power 2 over 3. I want to open the bracket now, times 5 raised to the power 2 over 3. And so with this, I can apply my indices. Now I can see 2 and 2 the same. Look at this, check this out. 2 and 2 are the same. So I can apply my indices. And I can see 5 and 5 the same. I can apply my laws of indices, which is division index. Which is division index. Moving on to the next, which is division index. Moving on to the next, I'm going to have now, so I have 2 raised to the power 2 over 3. I have 2 to the power of 3 over 3 minus 2 over 3, then times 5 to the power of 2 over 3 minus 2 over 3, according to the power index. All right, so by the time I multiply this, what I'm going to have will be 2 raised to the power 1. Then, because 3 over 3 minus, um, minus 2 over 3, that's going to give us 1 over 3. Okay, then times, this is 5 raised to the power 0. And remember, anything raised to the power 0 is 1. So I have 2 raised to the power 1 over 3 times 1, which is equals to 2 raised to the power 1 over 3. And that's my final answer in indices. Now, I can decide to express this as a normal fraction. So I can still put this as roots, the cube roots, because that's a fraction index, right? So I can say the cube root of 2 to the power of 1. And I have my answer, whichever way I like. All right, so that's on the first example that we're going to take. All right, and let's look at another. Let's look at another example. Now, this question says we should simplify. We should simplify. Look at this question now. It says simplify the cube root of 64 r raised to the power minus 6 raised to the power 1 over 2. Simplify 64r raised to the power minus 6 raised to the power 1 over 2. So we are to simplify that. So what do you think is going to be the first step? So just take 1 minute, look at the question, and come back. All right, welcome back. So what did you think about the question? Let us try to attempt the question. Now look at that clearly. If I want to interpret that question also means, it also means this. 64r is power minus 6 raised to power 1 over 2 raised to power 1 over 3. So the fraction index there indicated the roots. And remember, according to power index, if I should multiply these two together, I'm going to have to apply power index here to multiply these two together. And if I should do that, I'm going to be having 64r raised to power minus 6 to the power of 1 over 6. Now, we have two things there. We have two numbers there. We have 64 and we have r. So in order for us to open the bracket, I, we're going to do this. It's going to be 64 raised to power 1 over 6 times r raised to power minus 6 times 1 over 6. Bracket open. Now, 64 can also be expressed as 2 raised to power 6. So if 64 is 2 raised to power 6 raised to power 1 over 6, then times 6 is going to cancel 6 here. So I'm having r raised to power minus 1. If I apply power index here, it's going to be the same. So I'm going to be having 2 raised to power 6 times 1 over 6. So 6 will cancel 6 times r raised to power minus 1. So my answer is 2r raised to power minus 1, which means 2 times 1 over r, negative index, which is equals to 2 over r in the simplified form. And that is my final answer. That is my final answer. Let's take another example. We asked to simplify root of 160 r squared plus root of 71 r raised to power 4 plus, let's put this downwards. So I have root of 160 r squared plus root of 71 r raised to power 4 plus root of 100 r raised to power 8. All right, so let's break this down. Let us break this down. So I have the square root of 160 r raised to power 2, and I also have another square root attached to it of 71 r raised to power 4, and then I have another square root attached to it as 100 r raised to power 8. I know that let's break it down one by one. So root 100 r raised to power 8 is the same thing as 100 r raised to power 8 power 1 over 2. Remember, this is square root. So square root, you don't need to put 2 there because it's already square root. So this can also be interpreted as this in the fraction index. Remember the laws? And if I should apply the power index, it's going to have to multiply each other. And so we're going to be having 100. Now, we have two numbers there. We have two things there, 100 and r. So it's going to be 100 raised to power 1 over 2 times r raised to power 8 times 1 over 2. Let's continue. Now, 2, we cancel this 4 times. So we're going to be left with 100 raised to power 1 over 2 times r raised to power 4. And 100 can also be expressed as 10 raised to power 2. So I have 100, 10 raised to power 2. I have 10 raised to power 2 power 1 over 2 times r raised to power 4. Now remember power index. This is also power index. It means that we're going to multiply it together. So 2, we cancel 2. 2, we cancel 2, and we're left with 10 times r raised to power 4, which is equals to 10r raised to power 4. But we're not done. We just finished the first root, that's the one of the 100. We still have the one of the 71r raised to power 4 as well. So we're going to have now, it's going to be 160 r raised to power 2 plus 71 r raised to power 4 plus 10 r raised to power 4. Now you can see that they're both having r raised to power 4, r raised to power 4. So it is simple for us to add them together because they're having the same variable, which is r raised to power 4, just like adding algebra. So I'm going to be having 160 r raised to power 2 plus square root of 81 r raised to power 4. And so let us break this down. Let's break down 81 r raised to power 4. So I can write this as 81 r raised to power 4 raised to power 1 over 2. Remember, this is square root, and square root is 1 over 2, right? Raised to power 1 over 2. And so I will have, I know that 81 is 9 raised to power 2. So I have 9 raised to power 2 power 1 over 2 times r raised to power 4 times 1 over 2. Remember power index? 2, we cancel 2, 2 here 1, 2 here 2. So I'm left with what? 9 r raised to power 2. Now that we have broken that down, we're to add it back. So I'm going to have 160 r raised to power 2 plus 9 r raised to power 2. And it's very easy from here. I'm having 169 r raised to power 2. And what's the square root of 169? 13. And what's the square root of r squared? R. And that's going to be my final answer. So you can feel free to ask questions um, if you like, because I'll be dropping down your classwork. And you can check the classroom. You're going to see your classwork. You can do the classwork, your exercises. So feel free to drop down questions when we have our live classes, or you can put down your comments in the classroom, the Google Classroom. I'll be able to answer those comments and your questions. I'll be able to answer them. Thank you. So we've looked at some ordinary indices problem or initial problems. So in our next class, we're going to be treating indices in algebraic terms and algebraic powers, which is going to include indices involving equations, and is also going to include simultaneous linear equations in nature. But that is after we're done with the correction of our classwork and assignments with your questions as well. So you need to ask questions on that in order for us to get to you. So I'll see you tomorrow. Have a nice day.